Dave Truss here with Joe Truss, and we are going to do a sort of a response video. The video that we're looking at is on Star Talk with Neil deGrasse Tyson, and his guest is Sarah Amari Walker. And Sarah is one of the key scientists behind the idea of assembly theory. And so we're going to look at assembly theory from a perspective of the idea that we live in a tetraverse. I'm going to share a link to the video where we discuss that, and we will see a small clip of that video, but I'll have Joe very briefly describe what we're talking about when we say we live in a tetraverse.
Yeah, so the simplified but basic understanding of the tetraverse is that if you use a tetrahedron as your basic model, as opposed to the XYZ 90-degree coordinate system, you get a system where you have 4 axes coming from the center. Now, this is an alternative to the XYZ, but it's also complementary. When you put these two things together, the XYZ and the tetraverse, you get a 7-axis system that then gives you a much more robust way of looking at structures in particular. So the tetraverse works on the aspect of 4 aspects of these axes. It's alternative but complementary to XYZ 90 degrees. When you put these two things together, the 60 degrees and the 90 degrees give you an aspect of reality, of nature as it is, of structure, that you do not get only with the XYZ coordinate system.
Yeah, and one of the things that comes up as a common theme when we discuss this is that idea of resolution. And so
Right.
XYZ works, but as you go closer and closer to a Planck length, structurally it's not stable enough. It's necessary for description, but not sufficient if you want to go to the finest resolution. And
Right. And so this next part of the video with you, Dave, is actually going to demonstrate that if the universe by chance put together a cube rather than a tetrahedron, we know very much the triangle is the smallest frame. So we know that's got to be built, right? So tetras are going to come. But we model our world and the real number line of mathematics as cubicles using the 90-degree axis only. And so what we want to show is that, in fact, every cube that you make, we put these intersecting tetrahedrons inside that become the diagonal of that cube. And that is a 3-dimensional structure. So everything on your real number line of the XYZ has a shaft going off, right? And what happens if you use the shaft instead of the cubic edge is you get down to the fundamental, what we call unit 1 perspective, which is, let's assume that in a quantum world, the Planck constant distance defines the smallest distance that you can have within a structure. And when we apply that, we call that the unit 1. We base our discrete mathematics on the basis of this unit 1 factor, which is the diagonal of the square of the cube. And these diagonals all fit in tetras running off in a different perspective in terms of dimension.
yes.
And
Okay.
so if you show that video, play that clip, please.
Yeah, and before we play the clip, the one thing I want to say is we're going to look at assembly theory. And assembly theory talks about the complexity of the building blocks of of life and the requirement of life in order to get more and more complex compounds built. But one of the things that's interesting about the XYZ cube universe is there is no complexity. It's just a completely continuous building of blocks. Whereas there's an innate complexity that comes into a tetraverse where other shapes are automatically developed within different frequencies.
Right, so more like a fractal expansion, because the main shape stays the same, but all of the interior stuff becomes more and more complex. And we show that as a part of the tetraverse video.
Yes. Okay, so let's start with having a look at this discussion with Sarah Amari Walker on Star Talk.
Where exactly does spontaneity and selection cross, and how do you identify which is which? Which is a progression and which is a cross
Yeah. So
pollination?
The kinds of very simple molecules that might happen on a planet, can happen spontaneously. Or if you're thinking like Lego are easier for people than chemistry, if you have like a tray with a bunch of Lego in it and you shake it, you're going to get some Lego sticking together and making simple shapes. So those would
Okay.
be spontaneous objects. But you're not going to be able to shake it long enough to have Hogwarts Castle spontaneously emerge out of it. That would require a process of evolution and refinement.
And a
building.
wand.
And a wand,
Okay,
yeah.
that's
No
especially the
magic,
wand.
though. The universe doesn't have magic.
Oh,
At least not in this scenario.
I don't think we need to get into that part. So do you
Yeah.
want to discuss that a little bit?
Yeah, so in assembly theory, limited understanding, I'm a layperson, trying to access this with our own geometric representations. But in assembly theory, essentially, it's like if you shake these Lego blocks together, some things are going to stick.
Yeah.
Now, in terms of what is the precursor of life, that's the amino acid. So in this theory, as in theory of biology and life, the amino acid is the basic building block. You can't have life without the amino acid. That's pretty much kind of established. In our system, the amino acid is represented by the tetrahedron.
Mhm.
So the tetrahedron is the basic building blocks of the amino acids as an example. But what we show is how that single tetrahedron re-represents itself at different levels of frequency. What is a frequency? We establish a unit 1. A frequency is the doubling of that unit 1, adding to it. So I can have a 2-frequency tetra. It still looks like a tetrahedron, but the internal structure has changed. A 3-frequency, and it gets bigger. At the end of this video, we'll show you a 4-frequency tetrahedron, which has inside of it an object called the cube octahedron, which plays massively in our hypothesis.
But first, let's start with the foundation and the very basis. So we're going to share a bit of our We Live in a Tetraverse video right now. And we've already talked about the idea that the cube is floppy, right? So if you build a cube as a structure, it's floppy. And so what happens to a cube on the Planck level, the smallest possible level, is tetrahedral shapes are naturally where a floppy cube would move to. And so let's move to that right now. Tetrahedron being this shape here.
Exactly, the primary 4 triangular faces put together. So what we have on Dave's left-hand side, the new object, is a tetrahedron connected to an octahedron connected to a tetrahedron. And the way that was built was the cube collapse. That's all. When the cube collapses, every one of those square faces can only collapse down to that level. And so 6 faces of the cube collapse into that object that Dave is now holding.
Yeah, the 6 triangles there. I'm about to add them. I'll make them green so that we can see the different shape. But this is the same cube with a yellow added in between each square face to make them into 2 triangles. So I'm going to do that now here. And so what I do is I create.
That's right. And remember, none of those collapsing faces can get any closer than that distance that Dave is putting in. So you can't say, oh, well, maybe it'll collapse further. It can't collapse further because it's limited by that logical proposition that we introduced, which is there is a finite distance, an edge length that you cannot go beyond. This is what we mean by the quantum realm. It's called the Planck constant, P-L-A-N-C-K, the name of a famous physicist, cosmologist.
Yeah.
And that's what we're doing. So what we call unit 1 is simply the smallest possible distance that you can have in nature today, which is agreed by science in quantum mechanics.
Okay. I don't know if we want to continue or do you want to discuss this?
Yeah, I think we can just reinforce that concept, right? Now, in relativity theory, Einstein as an example, everything is continuous. So that description of reality that worked incredibly well in the large-scale universe is basically that energy, everything is continuous. The quantum realm says, no, everything is not continuous. There are gaps. There are quanta of energy. And that means that every one of these pieces of energy are basically down to a unit. Now, that size is not measurable, what we're talking about, right? So you can call it like a dimensionless number. So we take that dimensionless number of what the meaning of a Planck distance means, and we've applied it to the geometry of these structures. and you find that logically, consistently, right? If you just start with that single plank line, whatever that means, and you jiggle it like the Lego, edges are going to stick. You're going to build tetras, and cubes are going to come naturally out of it. When we look at what the universe builds as the Lego set, every cube that it builds will eventually collapse into a tetra, octa, tetra. Our claim in Tetraverse, which will come in another video, is that this component of a tetrahedron with an octahedron and a tetrahedron, I can rebuild or create any object or structure that exists in the universe that's known. We can build out of this single component. And I think that's just an absolutely fabulous kind of finding. And the assembly theory takes to the level of complexity to move these structures into accommodating life. We talk about the octahedron as allowing flows through and to accommodate life. Assembly theory says that these structures will evolve to a certain level of complexity, but life itself is the next step in continuing the selection process of reducing this massive space around one molecule in terms of the number. So it's selection. It's like Darwin's selection in life applies at this level. And assembly theory is saying that these indices of complexity are a threshold beyond which you have to have life in order to get the evolution of selection, the choice out of this massive space of what is the next one. And then, of course, you have to have memory of that's transferred through generations of structures and so on. We won't deal with that, but we're showing logically in terms of the geometry that an application of quantum theory that says that there is this distance that you cannot go beyond can be represented in three-dimensional geometry. And that this form, the tetra, octa, tetra, that we put together that comes out of a folded cube, of a floppy cube, is the basis. This is the component from which I can build every structure that exists in the universe that we know about.
Right. And I cut back to this video because you're using the term tetra, octa, tetra. And I just want to clarify that if you look at the image on the right side of the screen, right?
Right.
The blue corners are tetrahedrons,
right?
Either side. The middle one made out of the yellow and the green is an octahedron. That's two pyramids stuck together, right?
Base to base.
Base to base. So there is a square in there that's the base inside of that's already constructed. But when you say tetra, octa, tetra, what you're saying is tetrahedron, octahedron, tetrahedron created just by taking the floppy cube and pushing it so that each of the sides gets pushed down in its floppiness to the smallest possible point, which is another Planck length, just like the edge length, right? And I wanted to say that. So these are things right here that when you talk about assembly theory, you can shake the Lego and you will come up with these pieces. But there comes a limit to what you can actually construct as far as complexity by just doing the shake. So let's go back to the video here where she goes on a little bit more and go from here.
We have predicted that there should be a threshold above which only molecules produced by life should reside, and we've tested that experimentally.
Wait. Say, I missed that.
The universe can generate simple molecules. It can't generate complex molecules without evolution and selection. That suggests a boundary.
Experiment.
Yes,
right.
A boundary that just random chemistry can explore, but it can't go beyond.
Oh.
We've tested that with living and non-living samples, and even some that NASA sent, and this was done by Lee Cronin's lab. They sent him samples and they blinded them, and they tried to a blinded sample is one that you don't know the identity of the sample, and they tried to really trick them. They sent them Murchison meteorite, which is one of the most complex inorganic, non-biological samples in the solar system, and it's still classified. The experimental approach still classified it correctly as non-living. And what we saw was only the living samples had an assembly index value, this number of minimal steps above 15, which is not a magic number. It's just an experimentally confirmed number.
So you're suggesting that nowhere in the universe, without some other driving force behind the system, would give you a complexity higher than this
About 15, but that was for a specific set of chemical like kinds of bonds that can form. So we don't know if 15 is a universal number. It might be
Right.
different in a different planet with different geochemistry.
But the threshold is there
Yeah.
is the point.
So that was the first prediction that we've made that we've tested. And also the other thing that we have that hasn't come out yet is actually constructing phylogenetic
It
trees.
hasn't been published yet.
Hasn't been published yet.
Okay, we won't get into that. But there we have a very interesting point. I almost feel like we need to jump right into our video for us to talk about how that complexity changes, and then we can go. So should we just move straight to that?
Yeah.
So a little bit of background here. What we're talking about is the shape in front of me. It's not fully constructed because we're gonna tear it apart. But what we have here is when you build tetrahedrons on greater frequencies, and when we say frequencies, we're talking about the edge length. So this here would be a 4-frequency tetrahedron, in that each edge length is 4 of those Planck lengths, or that minimum length. That is on all of its 4 sides. The 3 sides that are on facing and the base would be 4 by 4 by 4. And so the key thing that's different than a cube universe moving to a tetrahedral universe is a cube universe just builds cubes upon cubes upon cubes. A tetrahedral universe, you innately get some key shapes that are automatically constructed. Things like hexagons, like octahedrons. And what we're going to demonstrate is the cube octahedron, which is kind of key for us to connect this to assembly theory. Is these are things that can be constructed without the interference of life, because they can be formed just by the shaking, just by the construction of triangles forming naturally because of the structure that's built there. So let's move on and just watch this for a moment.
Right.
So you can see the back sides here I've left open, but I'm going to show you why for a second. So what we have here is a 1, 2, 3, 4 frequency tetrahedron. And again, all we're doing is building bottom triangles and stacking them up. But a new shape forms, which is really fascinating. And it's easier to see on this side where I've removed, let me remove these. These were just to demonstrate that it's a 4 frequency. So what we have inside here is called a cube octahedron. You want to talk a little bit about that?
Yeah, I have a model here. I think that we can kind of show a little bit about what this cube octahedron is like. So
Sure.
what we see is that the cube octahedron is a natural, complex ingrowth of an expanding tetrahedron. And in fact, what we found is that these are the only 4 expansions. Then you get into doubling. Like a 2 frequency and a 4 frequency and a 6 and an 8 are going to have the same form internally. A 3 frequency is going to have the same hexagons on the sides, doubled. And the 4 frequency, this magical cube octahedron appears from the center of that 4 frequency. And that is basically, the cube octahedron is the basis of our hypothesis, because this shape, the cube octahedron, in Dave's model, you can see that the light green radial spokes that come out that support the cube octahedron in here, this is the only structure known in universe where the radius, there's a sphere that surrounds this form where every vertex touches the sphere. And from the center of this sphere to any of the vertices is actually the same thing as the edge length of the tetrahedron. It's the only form that does that. Now, the good thing about this is if I remove those internal structures, this structure becomes floppy.
Okay, before you go to that, because that's very important when we're talking about and looking at assembly theory. But I just want to go back to one thing you said. You talked about the doubling and the doubling. So a perfect example is this is a 4 frequency that we see right here. If we doubled that to an 8 frequency, this cube octahedron is now doubled. And so what happens is you have a 2 frequency cube octahedron inside of an 8. And so the complexity is there, right? But it's just formed and it can create something slightly larger. But there are limits to it, which matches with assembly theory, in that just like, for instance, an example that we discussed before taping was the idea of crystals, right?
Yeah.
Crystals will naturally form in nature. That life isn't needed, evolution isn't needed to create crystals. but the complexity of a crystal isn't such that something more complex is built if it gets larger. It just becomes a larger crystal. And so the part about this that is so unique, when you hold up that cube octahedron, if you could hold it up, right? This is the basis for our universe in the sense that this shape can uniformly expand like our universe, our flat universe, in the sense that this will grow evenly in every direction with stability
And without distortion, without
and
any form.
without distortion. Go
This
ahead.
is expandable as large as you want it, and it will maintain this perfect sphere where the radius and the edge length are the same. So with the cube octahedron, as I said, the thing about this is that we showed that this came out of a 4-frequency tetrahedron. So we use the term, we're not the only people that use this term, in-hyphen formation. Information being something that is pre-informed within the structure itself. You don't need any other external forces in order to have these things emerge. And so in this structure, as an example, coming out of the inside of a 4-frequency tetrahedron, if I take those inside radial struts away, I can then make this structure oscillate. Now notice, when I oscillate the structure, look what's happening with this square. Remember what Dave did with the floppy cube? Exactly the same thing. Every one of these 6 squares is going to collapse, but it can't collapse any closer than the unit 1 of the edge length. And you know what this structure is? It's an icosahedron. I think I've got one here that I can show quickly. There we go. This is the icosahedron, which is the basis of Buckminster Fuller's geodesic dome. And it's actually also the basis of the model that's used by loop quantum gravity. But they build it out of 20 tetrahedrons, which is a completely different kind of way of doing this than the way that we do it. So rather than going from, well, if this is the central aspect, and out of this form comes the tetrahedron, octahedron, tetrahedron that we showed, out of which you can build anything in universe, because every one of those tetrahedron, octahedron, tetrahedron is like a ray, an ray, that's emanating from the center through the triangular face. And there are 8 of those.
Yeah. So just to make that visually possible for people, if you hold that, if you imagine that it has the structure that we have here, let me actually bring back that image that we had here.
And then I want to show one other thing about this model.
Yeah. So if you look at this shape here, you can see the lighter green is right. Let's look at the top lighter green upside down tetrahedron. That's a tetrahedron, but if you follow that up to the orange part above it, you see that's a green upside down internal structure coming from inside the cube octahedron.
Right.
And then above it, you see octahedron. So tetrahedron, octahedron, and then the very top of the triangle is another tetrahedron. Tetra, octa, tetra.
And you can do that out of each of the 8 triangular faces of the cube octahedron.
So one of the things that I just want to say, because this is based on what you were saying there, when you talked about the rays, the RAYS, the rays coming out, if you hold that up, hold that up, right? If you imagine the structure of the universe being built in our flat universe, each one of those triangles has a ray going out that is a continual tetra, octa, tetra, moving omnidirectionally. Structurally, as they get bigger, there is no distortion.
Right.
There's no distortion. If you look at X, Y, Z, and you just work on those axes, as you expand, the gaps between those get larger and larger. And at some point, the structure is going to buckle because it's going to be too big. With the cube octahedron as the central force of a tetrahedral universe, we get continual expansion without distortion and maintaining its structural integrity. And I think that's something really important, but that doesn't allow for infinite complexity. It allows for an innate amount of complexity, right? Where you're not just seeing triangles, but you're seeing triangles, you're seeing octahedrons, you're seeing hexagons, you're seeing cube octahedrons. But for life to exist, there has to be another set of complexity, and that's where the icosahedron comes in.
That's correct. So when I compress this, and every square face gets triangulated by that unit 1, I have automatically built an icosahedron. And so if you look at a cube octahedron, you will not find a Fibonacci sequence,
Yes.
right? But you look at the icosahedron, every opposing edge of the icosahedron, if I connect up the connecting line, is a Fibonacci rectangle, a golden rectangle. And how does that relate to life? Everything in life today is almost based on that Fibonacci spiral. The way plants grow, the way your circulatory system works inside of your body. Without that Fibonacci, without that golden rectangle. So the cube octahedral world is what gives us the unlimited expansion omnidirectionally without distortion, but it is the oscillation that brings the Fibonacci sequence. It's that oscillation that actually allows life then to go. And so remember, every cube octahedron that doesn't have the internal part can only collapse down to an icosahedron. It can't collapse any further. So the limit in this situation is that Planck constant unit 1. Once we establish that you cannot infinitesimally then subdivide that unit 1 into smaller pieces, you have now a number line where every number is a discrete whole number. Now, it doesn't prevent me from having ratios. I can't have a ratio of half of the unit 1, but half of 2 is 1. You can't have half of 3. Half of 4 is 2. Half of 6 is 3. And that's why the universe doubles. That brings us to what we call the wave function of the frequency of an octave. Middle C on the piano, back to Pythagoras, and you ram that up to double the number of vibrations, you get a higher octave C. And we have a claim that says arithmetically the electromagnetic spectrum is built out of 72 of these doublings, from the highest energy gamma ray doubled all the way down to the longest radio wave, are 72 doublings.
I'm going to pause you there, though, because I want to say that, we do have an introductory video to the Tetraverse, and that's something that we can share. But the piece that I'd like to go back to is that idea of assembly theory. And so assembly theory, I think one of the pieces that we look at is when you look at the icosahedron versus the cube octahedron. The cube octahedron allows for continual growth and expansion, right? Which life doesn't permit that, The icosahedron, when you start building on top of the smallest icosahedron, you are going to run interference with yourself. And so the shape itself has limits, and it's those limits that allow for life. You can't have a tree that grows to an infinite size. You have to have that limit.
A constraint.
Right. And so the connection here to assembly theory is, I think that assembly theory works and makes more sense in a tetrahedral universe than a cube universe. And the reason for that is because there's only, like shaking the Lego, right? You can only get certain complex things. You need life to interject to now take the same triangular shapes and create a DNA spiral. Cubes don't allow for vortexes, but triangular shapes combined can create tubes, and we can't live without tubes.
And sort of cube octahedron, you can actually get vortices.
Yes.
Yeah.
Right. And so with assembly theory, I think if you started with a tetrahedral universe, you can make sense of there, A, being limits before life, and B, understanding how life can be produced through nature taking both the infinite expansion of a cube octahedron and the limits of an icosahedron, while also embedded in that is Fibonacci and spirals and natural growth that life needs in order to, at least in our universe, and for that, in order to accomplish the complexity that a life allows.
Yeah, and one of the other aspects as well is very important, not just to assembly theory, but to physics and science, is something called the phase transition, right? They love that. Neil deGrasse Tyson talks about that as well. They love phase transitions because you move from one configuration and suddenly you're in another configuration. It's kind of like a black box of how you can get to place to place. The last thing I want to show you in this model is that if I continue bringing the model down, I come to an octahedron. But I cannot compress any further.
Yeah.
That's it. It's stuck. But if I release that and twist it in the opposite direction, a phase shift, I can collapse it right down to, it is floppy. I'm trying to keep my hands up. A tetrahedron.
Yeah.
But this tetrahedron has 4 edges. What does that mean? It's a 4-frequency tetrahedron that expands out into a cube octahedron. And so from this basic form, and in loop quantum gravity, they claim that the Planck distance is the edge length of a tetrahedron. And what we say is that if that was the case, the tetrahedron would violate itself because the radius of the tetrahedron is far less than 1. Only this structure, you get the radius and the edge length being the same. And this is the only geometric structure in the universe that does that. So if you want to define an ever-expanding, omnidirectional, expanding universe, geometrically, this is the only frame that you can use. If you want to talk about life geometrically, you have to talk about the ICOSA. And what we're claiming is that this oscillation and breath is something that's fundamental to the very deepest limits of nature. Why do things move at all? Why is there anything? Way before life, structure had to evolve into conditions that allowed life. And then when life occupies it, life then becomes a selection process of choosing out of this massive space, where do you go next, right? And so that limit of this space is something that requires more than just the shaking of the Legos, according to assembly theory. You then need the introduction of a phase shift. And as a matter of fact, I can collapse this model all the way down to the basic primitive triangle. And there's no way logically or mathematically that you can get beyond the fact that this is the smallest enclosure of space imaginable. And if we make this space out of the Planck, what we call unit 1, then we have a discrete mathematics that is along a real number line that's running connected to the number line of XYZ. The last thing I want to show you very quickly is that as there are 8 triangles in the cube octahedron, there are 6 squares. And if I align it this way, these 6 squares give you the XYZ.
Nice.
The 90 degrees. It's the combination of the 90 degrees and the 60 degrees that gives both the expansion of the universe and the constraints that will allow life itself to evolve.
Excellent place to end. Thanks.